Now let us learn how to pass a array to a function. So we have an array, we have to pass it to a function, and let us say we have to sort an array, but doing using functions. So the target is that we have to sort an array. Sort means that we have to put the array in order, either an ascending order or a descending order. Let us say we have an integer array and we have to sort it, but the sorting thing, we have to write that sorting code for sorting inside a function. And let us suppose that we are using a technique that we call as bubble sort. There are many ways to sort an array. One of the algorithms is called bubble sort. There is another that is called selection sort. Another is called insertion sort. Then there is quick sort, merge sort, heap sort. There are many algorithms, and some have a take less time to sort an array. Some take comparatively a larger amount of time to sort an array. So let us say in this program we are using bubble sort. What is bubble sort? For example, we have an array. We say 5, 2, 6, 8, 7, and 3. So we have an array consisting of 6 elements. If I have to sort this in ascending order using bubble sort, what does this bubble sort algorithm do? It compares the first two and it will see if the first element, that is 5, if the first is greater than the second. Since here the first is 5, the second is 2, so the first is greater than second, swapping will occur. So 2 will come to the place of 5 and 5 will go at the place of 2. Other things will remain like that. This is one first iteration. Then in the second iteration, what will be done? 2 will remain here, but now this 5 and 6 will be compared. So the second and the third element will be compared, which in C we say, if this array is called A, we say A of 1 and A of 2 will be compared. If A of 1 is greater than A of 2, then swapping will occur. If A of 1 is not greater than A of 2, then there will be no swapping. Same is the case here. So it will remain as such, 8, 7, 3. Then in the next iteration, A of 2 and A of 3 will be compared. So it will remain as such, 2, 5, because 6 is less than 8, so there will be no swapping. Then A of 3 and A of 4 will be compared. Since A of 3 is greater than A of 4, so swapping will occur. Swapping will occur, it will become 7 here and 8 here. 3 will remain as such. Then again, in the next step, this 8 and 3 will be compared. That means A of 4 and A of 5 will be compared. Since this is greater than this, so swapping will occur. and we will get this number, this array here. This whole thing is called one pass, P-A-S-S, pass. So how many steps were there? 1, 2, 3, 4, 5. So for this 6 numbers, we went for comparing. First we compared here, then here, 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 and here. Finally we get this thing. So we made 5 comparisons, and finally what we got is that the largest in this array has been taken to the rightmost position. In this original array, the largest number was 8. It has been taken to the rightmost position. In other words, only one number is sorted. Then we have to repeat this process multiple times so that all the numbers get sorted. One is sorted here, then we have to sort another one, then another one. So in the second pass, second number will be sorted. In the third pass, third number will be sorted, third greatest. In the fourth greatest will be sorted. In the fifth greatest will be sorted. And you don't need a sixth pass because the sixth will obviously be the smallest number here. So let us do the second pass here. Pass means that again we have to do it from left to right. So first we will compare a of 0 and a of 1. If a of 0 is greater than a of 1, swap. If it is not, keep it as such. So it will become, the first iteration of the second pass will be 2, 5, 6, 7, 3, 8. Second iteration, this and this is to be compared. So nothing will happen. So it will remain as such, 2, 5, 6, 7, 3, 8. Then 6 and 7. Nothing will happen. 2, 5, 6, 7, 3, 8. Then 7 and 3. 7 is greater than 3, so swapping will occur. 2, 5, 6, 3, 7, 8. Then 7 and 8 will be compared. 8. And these will be the 5 steps of the second pass. After second pass, we will see that this 7 is at its correct place. It has reached its correct place. Second greatest has reached to its correct place. And this process is to be repeated n minus 1 times. The n is the number of elements in this. And we can also remove one iteration here, because if we don't compare 7 and 8, it is okay, because we already know that the 8 is the largest, it is at this position. So this one iteration can also be removed to save time. And here this is pass 1, this is pass 2, then we have to go for pass 3, and so on. Finally, after n minus 1 passes, we will find that all elements, we will get them in a sorted manner. Let us now start writing code for this bubble sort and also put that in a function. So let us say we create a function, and this function will do the sorting part, and let us uh, say it doesn't return anything, but it does the sorting thing. So let us call it b sort, the function as b sort, bubble sort. And what we have to pass to this function, an integer array we have to pass. Now let us go to main and create an array. So let us say I have an array, its name is a, and the size of array I keep n, and I ask the user to enter the size of array. Scan that, ampersand n, then we will ask the user for the array, enter the elements of the array, enter the e- element of the integer array, scan that array, elements of array, and the name of array is a. And since the array will have multiple elements, we will use an I here, and to scan many things, many elements, we need a for loop. So the for loop will run from 0 to n, 0 to n minus 1, and this scanning will be done. Now we created an array, the size of array is n, and what is there inside the array, we scan it here. Now we have those elements also of the array. Now we need to call a function that will do the sorting part for us. So we have already created this, defined the function b sort, bubble sort. We will pass a to this function. This function will do the sorting. And another thing we are learning here is that we are not just passing an integer, we are passing an array here. A is not a single integer, it is an integer array. So we are passing as a parameter an integer array to this function b sort. Now after main, let me define this b sort function. What is it taking? This b sort function is taking an integer array. Let me call that array x. Fine. And we also don't know the size of this array. That means we also need to send the size here. So we need to write here b sort a comma n, because this function does not know the size of this array. So we also need to tell this function that the size of the array is n. So here I will also take int the size, for example s. So the size of the array, which is n, will be copied to s, and the array itself will be copied to x. And here also I need to write in definition int comma int, an array, and also this thing. So once we have received these two things here, the array and its size, now I have to write the main code, that is the code for sorting an array. So what is that thing? We need to develop that logic here. We have an array x, its size is s. Now we need to sort it. So for sorting this array, we need to compare the a0th element, the x0 element with x1, then x1 with x2, and x2 with x3. That means what I need to do is, if I have to compare x0 with x1, and if the first element is greater than the second element, I need to swap. I need to do the swapping part. So if this is true, what I need to do here, I have to do swap. How do we swap two numbers? Easy, we take a temporary variable, put the first number there, first is x of 0, then store, then write x of 0 equal to x of 1, then write x of 1 equal to temp. So this way, these two numbers x of 0 and x of 1 will be swapped, they will be interchanged. And this thing needs to be repeatedly done. So to it is better to write here, instead of 0 and 1, we can easily write j and j plus 1. Means that if this is 0, this will be 1. If this is 1, this will be 2. So the element and the next element will be compared. Similarly, we will convert this to j, here to j, this to j, this to j. So this way, all the elements of the in a single array will be compared. In other words, this thing will happen, a pass will complete. But to control this j and j plus 1, obviously we will need a for loop, because we need to change the value of j. So the j will start from 0, it will go to n minus 1 and j plus plus. So this for loop is for this I, if this I. What will happen? The first time this j will be 0 and j plus 1 will become 1. So the x0 and x1 will be compared. Then next time this will become 1. So j will become 1 and j plus 1 obviously will become 2. So next time x of 1 and x of 2 will be compared. That is why a bubble sort is. So this process will happen, and one pass will be done. By this code, from here until here, things will be done. So that means one pass will be completed. And since this has 6 elements, 1, 2, 3, 4, 5, 6, and we needed 1, 2, 3, 4, 5. So 5 iterations should be there. So that is why we wrote the code from 0 to n minus 1, 0 to less than n minus 1. So the total iterations will be n minus 1 because it starts from 0. Now uh, we can clearly see here that the sorting cannot be done in a single pass. You have to repeat this pass thing multiple times. In fact, n minus 1 times to do the required. So this whole code should be repeated for many passes. So that means this whole code from here to here should be repeated n minus 1 times. So I need to write another for loop here. Say I equal to 0, I less than n minus 1, I plus. This upper loop will control all these. This upper loop is applicable on this loop, and this loop has this body. We can do a little formatting here. For clear understanding, this loop is inside this loop, and this if is inside this loop. And since we have used I and j here, we must declare them here I, j, and we have also used temp also. Okay. So to create this many passes, we need another loop which we have put here. So this will create passes n minus 1. This will do the comparison part, and it will run again n minus 1 times in total, and it will do the swapping thing. We have done one mistake here, that this swapping is to be done between x and j plus 1. So it will be in first we will store x and j in temp, then inside x of j we will store x of j j plus 1, and then in j plus 1 we will store the temp. So this is a very simple logic to interchange the contents of two places of an array. This is done, swapping is done, and all passes are iterations are done in a pass, and all passes are done. Then the bubble sort logic is complete, and now we can print our answer, the array. So printing an array, we need obviously a for loop. We will write for I equal to 0, I less than n, which obviously here is s, which is I plus plus. We need to make this correction here also, because this is not n, this is s. The uh, the size of array which was n, we copied that in s. Done. Now here I need to print. So I will write printf percentage d, comma, the array which is x of I. The whole array will be printed, which is the answer. This is after swapping. So we can write here printf after sorting, not swapping, after sorting, we get this thing. After sorting, we get this array. Okay. And before sorting, we should also print the array so that we can compare the result. So here, before calling the sort algorithm, we should do the printing of the array. So here again we will do I equal to 0, I less than n, I plus plus, and write the printf for printing the array, which is percentage %d, and the array here is a of I. Then later we should call this thing for sorting. And this is the definition of bubble sort here, b sort. This will be the declaration. Since in the definition we are using an array here, in declaration also we should mention it here like this, that in future it will be an array of integer type. Now it seems that we are done, and we can say we should save this program. Let us say as bsort.c or bubble sort.c and compile it. I we have not declared here. Let us declare I. Here we have not put a comma. Let us put a comma here. And here we have forgot a semicolon. Okay, here it is printf, not printf. Okay. Enter the size of array. Let us say 6. Let us put the same elements in this array. So 5, 2, 6, 8, 7, 3. 5, 2, 6, 8, 7, 3. So we can see the entered is 52687 3, and after sorting we are getting 23567 8, which is the correct answer.